Welcome to Fisher's CPD session. In this CPD, we'll be showing you whether anchors are important, some bad practice example, and importance of complying with BS 8539 Code of Practice. Before we start, just quick introduction. My name is Mirka Valovičová. I'm Technical Manager of Fisher Fixings. In this session, we will be highlighting importance of correct anchor selection and installation. I will be showing you some bad practice examples, and that will lead us to very important code of practice, BS 8539, Code of Practice for correct anchor selection and installation. And at the end, I will show you how Fisher can help you to comply with this important code of practice. So correct selection of anchors. What needs to be considered and why? If you look on our website, you will see we have vast range of anchors. So how you select the best fixing for your job? You need to consider many different aspects. Substrate, what you are fixing into, what is your load, type of load, is it static variable load, fatigue load, dynamic load, type of anchorage, type of installation, environment, can you use plated anchors, do you need stainless steel, what type of stainless steel, and also what type of approval. All these factors are very, very important. We do have specific CPD just focusing on these topics. Importance of correct anchor selection. Are anchors important? What can go wrong? Consequences of bad practice. Unfortunately, yes, accidents do happen due to anchor failures, even some fatalities. We need to ask important question, why these accidents do happen. Reasons can be different, maybe incorrect installation, incorrect anchor selection, incorrect application design, change of specification, incorrect site testing, or lack of information sharing. Very often is a combination of few of these factors. For example, here in this example, you see the pull-out of resin anchor from old masonry. And later on, I will show you why this happened and how this can be avoided. So what are the typical challenges with anchor connections? Incorrect anchor selection, hitting the rebar, which might then cause possible reduction of embedment depth, applying correct installation torque, small edge distances or small axial spacings, use of shims, packers, insufficient hole cleaning, deviations from original design, and change of specification. So let's have a look at some of these bad practice examples in real life. Here we have example where we received a complaint to our technical helpline where end user called us complaining he was installing torque control expansion anchor and fixing was spinning. When they tried to apply installation torque, fixing was rotating in a drill hole. If you look at the application, you might see why this happened. Good product with ETA, but was used in wrong base material. This product is approved and suitable only for concrete, and end user was using it in masonry, and what was even worse, it was aerated block, very soft material. So of course, when they tried to expand the anchor, fixing was just crushing the soft material and fixing was spinning. So lesson learned, always check fixing suitability for the base material you are installing into. And in this case, because the load required was quite high, so what would be the better solution would be to use, for example, injection resin anchor with undercut hole, our PBB system, which allows you to drill undercut hole into the soft aerated block, and you will create very secure fixing, which rely on mechanical interlock in the base material. Here you can see fixing was installed with reduced embedment depth. Also here, the same issue. If you look at this example, this fixing was cut So we don't know what is the embedment depth of the anchor. Also, these two bolts are quite large diameter, so you would have to check what is the allowable minimum axial spacing. Here again, fixings were cut, so that will suggest maybe the effective embedment depth was reduced. And here the stud is protruding quite a lot. So again, I will be suspicious what is the actual embedment depth in that detail. For example, further examples of incorrect installations and consequences of hitting the rebar, because that is usually the reason. You are drilling, hitting the rebar, you can't drill deep enough and you are reducing embedment depth. So that wouldn't be our recommendation, to use additional washers to compensate. That is not best practice, or drilling under angle. Of course, that fixing now is overstressed, so it's not safe. And further examples, when we zoom in, you will see some anchors, again, haven't been installed deep enough. So, what action should be taken if rebar is unexpectedly encountered at a depth less than required drill hole depth? There is very detailed guidance in a Code of Practice, BS 8539. You must always refer this to the supervisor and the engineer, what action should be taken. And please never install anchor with reduced embedment depth, don't cut the anchor rod short, or install anchors at the angle to avoid the rebar. Why it is important to make sure that sufficient embedment depth is achieved. Like here, we see the fixing most likely is not embedded deep enough into concrete. Why this is important? Of course, the load capacity depends on embedment depth. If you are reducing it, you will be reducing the design resistance of the anchor. So typical concrete cone, I have a small example here. The cone diameter and the design resistance would directly depending on the embedment depth, age effective. Now question, if you install the fixing and you see this detail, how do you check what is the actual embedment in that concrete? Because as soon as the fixing is installed, you can't take it out. So if you want to refer back and double check what embedment depth is on the actual application and calculate backwards what is the design resistance of that anchor, you can actually check it afterwards, because when you look at the fixing, refer to the head marking. We have different letters for different fixing lengths. So if you check your head marking, in this case, it's capital B in a bracket, that will tell us very clearly when you look in the ETA, European Technical Assessment, you will be able to define, in this case, what was installed was FAZ 212/10. You can see damage to the substrate. And here as well, if you look at this lamppost connection, when we zoom in, you will see the damage to concrete due to small edge distance. This was 16 mm diameter toe control expansion fixing, installed only 50 mm from the free edge. So no surprise, big damage to the substrate was done during installation. And some frightening examples here, further accidents waiting to happen. Here, installers try to gain a little bit of edge distance, installing that anchor and the angle, but of course, that's example of bad practice. We can't rely on connections like this. I will show you a video from our training room where I will demonstrate what happens if you install expansion anchor close to free edge. see, fixing is not set fully and already big damage to the concrete. And you can see how far the stress travel, far away from the fixing. So big part of the concrete is damaged. And you can see the crack going also further down, probably twice embedment depth, around 70 mil deep into concrete. 80 millimeter damage. So that video very clearly demonstrated why it is important to observe the minimum allowable edge distance specified. For that anchor I was installing, that was ETA M10, the minimum allowable edge distance is actually 150 mil. Okay, so if you don't have that available, what else you can do? For applications with small axial or edge distances, you should be considering other fixing system, for example, resin anchors, concrete screws, or undercut system, undercut anchors. These are expansion-free systems. That's why you can install it relatively close to free edge. For example, here you see the specification of concrete screw. If you take 10 mil concrete screw, you can install it 40 mil from the free edge. If you take FBN M12, that edge distance would have to be increased to 70 or 100 mil, depends on the concrete thickness. So massive difference. On this slide, I will show you some example from facade application. I went to site and we were observing some issues with fixing installation. Application was very simple to install these large windows with 3 brackets on each side. Each bracket fixed with 2 fixings, simple as that. Unfortunately, in some instances, end user decided to change the specification, and instead of installing 2 fixings here as originally designed, they installed 4 anchors, assuming, 4 fixings will be better than 2, yes? Unfortunately not. If you zoom in, you will see very frightening example. M12 expansion anchor installed with only 25 millimeter axial spacings. What that means, those fixings installed so close together will damage the concrete between the expansion clips. If you look at the minimum allowable axial spacing for FAZ12, it's 50 millimeters. In this case, we had only 25. If they use another type of toe control anchor, FBN, the minimum allowable axial spacing would have to be actually 70 millimeter. You might be wondering why this is different. It's to do with a different clip. FAZ has a double clip, so it's optimized. That's why with FAZ anchor, you can reduce axial spacing, but 50 millimeter, not like in this case, 25. Also, what is very, very, very important, in this case, they had also free edge. If you are introducing free edge on application, you need to check how you need to adjust the axial spacing. So for example, if you have edge distance of 60 millimeter from the anchor, then axial spacing has to be increased from 50 to 160 millimeters. To avoid the damage to the substrate. And even nylon fixing can cause the damage. Here we see the connection of large window and 2 nylon anchors installed in close proximity, close to free edge, and you see the damage to the substrate. And by the way, what do you reckon would be the minimum allowable edge distance if you take 10 mil SXR frame fixing? Let's have a look at a load table where you can find this information. So if you are installing SXR 10 in concrete, the minimum allowable edge distance is 85 millimeter. However, if you are installing 2 frame fixings and they are 70 millimeter apart, you need to increase edge distance from 85 to 210 millimeters. If you go into masonry, again, refer back to published data. What is the minimum edge distance in masonry? In this case, it would be 100 mil. So lesson learned, if you have connections where you have base plate with relatively small axial spacing and also free edge, refer to published data or use a design software because you have to evaluate the distances altogether. You will see the base plate is not clamped directly against the concrete. We do have quite a lot of packing. Okay? That might influence design of the anchor, especially if you have the load in shear. And this detail actually shows you how not to do it. You don't have to be structural engineer to see that bracket is not rigid, it will be rotating. So that is not the best detail how packing should be applied. Let's have a look what impact any non-load-bearing layers, for example, packing, shims or leveling mortar will have on a design. In this example, we do have application of 4 anchors and base plate is clamped directly against the concrete. We have 40 kilonewtons in shear over 4 anchors and design capacity is only 40%. Okay? If we are introducing non-load-bearing layers, in Fisher's C-Fix, you can model it very easily. And the base plate, you introduce now base plate with non-load-bearing layers, in this case 15 millimeters. And you will see that design utilized capacity now is 228%. So from 40, we went to 228. So that just shows how important it is to take this into account. If you have shear with non-load-bearing layers, you have to design it at shear with a lever arm. And another important fact, you have to ensure you have fixing which is long enough so embedment depth is not reduced, which is important if you have also tension acting on that application. And good news is software will automatically adjust the fixing lengths. So in this case, instead of 1210 fixing, now we do have 1230 fixing. So the fixture thickness has been increased, so the fixing now specified is longer. Now question to the audience. What is critical when you are installing toe control expansion anchor? What sometimes on site during installation is not happening with this type of anchors? Sometimes installers are not using calibrated torque wrench. They might not be applying the correct installation torque, which is very important because we do have specified installation torque to make sure the expansion clip is activated and fixing is correctly set. But also, on the other hand, we also have to measure installation torque because we don't want to overstress the fixing. And we come across scenarios as well. Installers might be using the impact wrenches because it's faster. But that is dangerous, especially if you are using and installing the smaller diameter anchors, because then it's more likely you will be overstressing the fixing. I will show you in this video what will happen if you overstress the anchor. Let's see what happens when we apply wrong installation torque on 8mm Facade. As you can see on the packaging, correct installation torque is 20 Newton meters. So let's see what happens if you are not measuring the value. We are reaching the point where we will be stressing the steel and we have a steel failure. So remember, lesson learned, always use the calibrated torque wrench set to the correct specified installation torque. So that video showed why it's always important to install anchor with correct installation torque. And this is an example of FAZ anchor. When you over tighten it, fixing is damaged usually below the expansion clip where you have reduced cross section. And information is on packaging, so very easy to follow the best practice. Here we have example of the design where designer specified 12 mm FAZ, 1230 with 70 mm embedment, and edge distance was 60 millimeters. So this is example from CFIX design model. And what happened in reality? You can see few issues here. Fixing was not installed with 60 mm edge. You will see the damage to the base material already due to small edge distance. Here you will see reduced embedment depth, and actually when we measured the length of the stud protruding, we could calculate backwards, and what was shocking, not only reduce edge distance, but also reduce edge effective from 70 to only 27 millimeter. And plastic shims. Shims should be underneath the full base plate as per the design. Importance of having correct installation accessories. All these are examples of failures due to installer not using correct installation accessories. So let's have a look now, installation of injection resin anchors. What is very important and very common issue on installation of injection resin anchors? What is usually not used? Hole cleaning accessories. Okay? If you don't clean a hole correctly before you inject the resin into the drill hole, what will happen? It will reduce the design resistance of the anchor. I will show you in a video impact of not cleaning the drill hole correctly. So video showed why it is important to clean a hole correctly, to use correct installation accessories, blowout pump, and also metal brush. We provide guidance how to install the anchors correctly in installation leaflet we just applied with resin cartridge. And here you see the example of resin anchor which was pulled out. If you're a designer, you can actually eliminate this risk. Do you know how to eliminate this risk? You can specify, for example, RM2, also high bond glass capsule, where you don't have to clean a hole. You drill and insert a glass capsule and finish installation. You are eliminating the risk of drill hole not being cleaned correctly. Other option is you can specify use of hollow drill bit with dust extraction system, because then you are removing the dust during drilling process. So that's another way how you can eliminate risk of wrong hole cleaning. Of course, we try to help installers. We can issue method statement for specific projects. And we, of course, offer also toolbox talk training, where we provide training to the installers on a best practice and correct installation procedures. Another risk with anchors is change of specification. Sometimes specification is changed with not understanding that fixing, which might look the same, might be the same diameter, same length, but will not perform in the same way. Also, what is important to understand, it's not enough just to check the published performance values, for example, tensile resistance. You have to check other details. And I will show you an example why this is important. On one project, we were called into site because installers realized the bracket was overhanging the concrete. They had some chamfering, and the fixing was installed closer to free edge than originally specified. So we came to site, measured the edge distance was 45 millimeter. When we modeled the application, we could talk to the contractor, okay, even though the edge distance was reduced to 45 millimeter, if FAZ anchor was installed, detail is still safe and it's correct. If they installed same diameter, same length, but FBN anchor, if you model it in a C-fix, you see that fixing wouldn't be sufficient because 45 millimeter wouldn't be allowable for FBN. So lesson learned, even if fixings look similar, they might not be suitable for the job. Always carry the full design process to make sure if you are changing specification, it's still correct and safe. So I hope I haven't scared you too much. These bad practice examples very clearly shows why it is important to design, procure and install the anchors correctly. Now, important questions. What can we do to eliminate the safety risk? Always remember, anchor failures can be prevented by correct anchor selection, correct design to the latest design codes, using the up-to-date design software, and everybody must follow very important code of practice, BS 8539. If you would like to learn more about this, we do have other CPD accredited seminars, and towards the end, just very quickly, a little bit about code of practice BS 8539, because it's a very important document. It promotes safety. Aim of the standard is to provide guidance on safe selection and safe installation of anchors for safety critical applications. This code of practice provides practical guidance for everybody involved with anchor selection and design, procurement and supply, installation, supervision, certification, and also anchor testing. Therefore, it is applicable to everybody, manufacturers, designers, specifiers, contractors, installers, supervisors, and also testers. We do have very useful summary for everybody. And if we very quickly just summarize the main points for the contractor. For safety critical application, you have to use products with an approval. Correct anchor must be sourced as specified. If you are using alternative anchor, change management procedures must be followed. Installers must be competent and trained. Installers should be supervised. Prior to anchor loading, anchor should be inspected by the supervisor. And upon completion, installation should be certified by the supervisor. And if you are doing site testing, then you have to follow CFA guidance note on site testing. Contractor must provide information required for the tester before the site testing is conducted. And tester should be certified by independent organization by CFA Construction Fixing Association. Now, important question. How to achieve compliance with BS 8539. Refer back to CFA website. You will find there very useful information about the code of practice. You can download very useful forms. CFA forms. There are different forms. For example, CFA form 853903 is installation certificate. So somebody has to check and declare where correct installation accessories have been used, correct anchor was installed, and supervisor have to sign the installation. Design software can be used as evidence. Instead of CFA form BS 853902, you can use printout from design software. In a printout, you will find out full anchor specification, full name, also article number. So you know you are procuring the fixing as specified and designed. Also, you have all design assumptions listed in detail, so it's easy to check whether correct design assumption have been used. And CFIX report provide also list of installation accessories with article number. So that will help procurement to get all important installation accessories as specified, and also guidance on installation. You have very detailed installation details. For example, in this case, we have the resin anchor. So we have information about the hole diameter, specified embedment depths, how much resin is required, and what is the correct installation torque to apply to the anchor. So as a quick recap, summary of the most common issues with anchors and what we have to follow. Anchor must be specified correctly and fully. Anchors must be procured as specified. If we are changing specification, follow BS 8539 with the change management. Make sure installers are competent and trained. Follow installation instructions. Always check you have correct installation tool and installation accessories. Don't reduce age effective. Always observe the minimum allowable axial and edge distances. Don't use shims unless provision was made for it in a design. Apply correct installation torque. If you are hitting the rebar, stop and check with the engineer what action should be taken. Maybe you have to reposition the anchor. If that's the case, you have to think how far you need to be from abandoned anchor. Don't modify the system. If you have any further questions, always refer back to manufacturers, calling technical helpline. Okay, as a summary, BS 8539 is a very important detailed code of practice. Don't take any risk, limit your liability, comply with this very important code of practice. How we can help you to comply with code of practice? We offer a vast range of ETA-approved products. We provide design support, so you can call our technical helpline. We have fantastic design software. We have Fisher Professional app, all are free of charge, so you can download it from our website. That will help you with correct design of anchors. So we offer, of course, also site support. If you need site consultations, we have a large team of well-trained engineers and technicians who can support you on site. We offer toolbox talk training, which can be done face-to-face, also online. And of course, we provide also site testing, and that is in accordance with BS 8539, according to the latest CFA guidance note, and our engineers and technicians are independently accredited as per BS 8539. Regarding the training, you can go to Fisher website. You will find different training topics, different levels, starting from introduction to fixings, nylon, steel, chemical anchors, also fixing solutions for M&E application, facade, concrete applications, also training videos about the passive fire protection. And for the installers, you can watch our toolbox talk training videos for different anchor systems. So utilize this as well. If you pass the test, you will get also training certificates emailed to you directly. And you can also download Fisher Professional app, which is very useful because you will have a lot of information on your fingertips, so you can find required information very easily in this app. And if you have any further questions, feel free to contact Fisher Technical Helpline on number 01491 827 920 or send us email technical@fisher.co.uk, and we'll be very happy to support you and answer any of your questions. Of course, if you want to learn more, let us know as well. We have many different topics, CPD accredited, so hopefully you will join us for other CPD training seminars. Thank you for watching.